So let's start with a big question. What does an AI's brain actually look like? I'm not talking about the code or the algorithms, I mean the physical thing. What would you see if you could, walk up to it? Well, it looks like a factory. Seriously, a massive, sprawling, humming factory just packed to the gills with servers. This is the physical body for that digital mind we talk so much about. And right now, building these quote-unquote AI factories is one of the biggest infrastructure projects on the entire planet. To really get a sense of just how big, we need to look at what's happening on the ground.
Okay, so to get a handle on the sheer scale of this, let's zero in on one of the world's biggest markets, China, because the numbers coming out of there, well, they're just staggering.
All right, get this. In 2026, just a couple years from now, the market for data center servers in China is expected to be worth over $15 billion. Think about that. That's a huge number for just one country in 1 year. But honestly, it's where that number is going that really tells the story here.
Because by 2031, just 5 years later, that market is projected to more than double. We're talking nearly $37 billion. This isn't just, steady growth. It's a full-on explosion.
And this right here? This number illustrates the sheer speed of it all. We're talking about a compound annual growth rate of over 19%. I mean, just try to imagine an industry growing by nearly a fifth every single year for 5 years straight. It's wild. So what on earth is driving all this demand? Well, here's your answer. Take a look at this chart. The key thing to notice is that huge slice right there. Over a third of all that server power is being used for just one thing: artificial intelligence and machine learning. That is the engine driving this entire construction boom. But these AI factories, they have a voracious appetite. And their first thirst is for power. I mean, running hundreds of thousands of these high-performance servers 24/7, it consumes an almost unimaginable amount of electricity. And that right there creates a very real and very tricky problem. To see this problem play out in the real world, let's head to Texas. The grid operator there, a group called ERCOT, is on the front lines. They're dealing with the explosive growth of these kinds of large-scale, power-hungry facilities, like crypto miners and data centers. And these places are so massive, they create brand new challenges for, just keeping the lights on for everyone else.
The key concept here is something called grid stability. And really the best way to think about it is like a tightrope walker's balancing act. The grid has to perfectly match the amount of electricity being generated with the amount being used every single second of every single day. If that balance gets thrown off, the whole system can collapse.
And that's the risk, right? When a single one of these AI factories can suddenly draw enough power for a small city, it's like someone instantly dropped a huge weight onto one side of that tightrope. It can destabilize the entire grid, and that could mean outages for everyone.
So, as you can imagine, keeping the grid stable with these new megaloads is incredibly complex. I mean, just look at this. This is a glimpse of the software models engineers have to build just to understand the risks. They're running countless simulations, trying to predict how the grid will react, all to make sure one AI factory doesn't accidentally cause a massive blackout. But, and this is a big but, power isn't the only resource these places are draining.
Which brings us to the next and maybe even more surprising challenge. Because there's another resource, one we don't often think about, that these AI factories consume in staggering amounts: water. And it's sparking a completely new kind of conflict. This quote from a legal analysis in Michigan just says it all. We're not talking about a little extra water for, the sprinklers outside. No. We are talking about consumption on the scale of an entire city, and it's all just to cool the servers so they don't overheat and literally melt.
Let's really put that into perspective for a second. A single large AI data center can gulp down up to 5 million gallons of water every single day. That's several times more than what an entire small city uses. It's an almost unbelievable figure, and it's happening as we speak. And here's the wild part. These conflicts aren't just happening in dry places like Arizona, where you might expect it. They're erupting in Michigan, the heart of the Great Lakes region, a place that holds over a fifth of all the surface freshwater on the entire planet. So you got to think, if water's becoming a battleground there, it can become a battleground anywhere.
So what's happening? Well, in response, landowners and communities are starting to fight back, and they're using a whole toolkit of legal strategies. They're challenging the public permits. They're filing official complaints when their own wells start running dry. They're even showing up and intervening directly in local zoning meetings to demand concessions before these places even get built.
So let's just zoom out for a second and look at the big picture. This new, intense thirst for data, power, and water, it doesn't exist in a vacuum, right? It's happening at the exact same time we're trying to solve some of our oldest and biggest environmental challenges.
And this creates a real fundamental tension. On one side, you've got the AI boom, which demands massive, concentrated resources, and it needs them right now. But on the other side, you have the rest of our physical world, where we're trying to achieve sustainability through slow, difficult, incremental gains, like making millions of individual homes more energy efficient over the course of decades. These two forces are pretty much on a collision course.
Which leaves us with one last, and I think, crucial question. We are absolutely racing to build the brain of the future, no doubt about it. But in our rush, are we paying enough attention to its body? As we chase this incredible promise of artificial intelligence, can we really afford its very real and very, very large physical footprint?